dimensions. Let's get into some more details about how these things work. So for implementing IPVPNs, when they were deciding what is the best way to go about providing this service, BGP was chosen as the routing protocol to provide this service. Now you might ask, why BGP? Because BGP is the only routing protocol that can support a large number of routes. If you are aware of routing, you know that BGP is the preferred protocol of choice for supporting the internet routing table, which is close to maybe 300,000 routes by now. But typically routers build their support for supporting up to 1 million routes or even more. So when we are talking of that kind of scale, BGP is the only routing protocol that can support such a large number of routes. One of the main reasons is that all it ensures is there is a keep alive message going between the peers, and it doesn't have to exchange all the information all the time like some of the other routing protocols do. So there is a significant reduction in the number of protocol packet exchanges. So that's why BGP is used. And another reason why you want to go with BGP is because it is very flexible in terms of supporting different kinds of protocols. All we need to do is say what type of information is being exchanged between the two routers, and as long as the two routers agree, you can exchange that information. Like for example, you can build extensions to support IPv6 routes, or in this particular case, the routes combined with the VPN for making them as VPN IPv4 routes. So it is very flexible in supporting different kinds of protocols. And a third big advantage of using the BGP as a routing protocol is that it doesn't mandate that the two routers which are BGP peers are directly connected. As long as there is connectivity between two routers, you can run BGP between them. Now this is a very big deal because it allows the VPN information not to be stored in the intermediate P routers. If you notice, the way service provider is going to build the network is that the P routers are really super fast routers, and you want to keep the load to a minimum in the P routers. You want to put all the intelligence towards the edge, and all the high-speed networking technologies would be handled by the P routers. So you don't want it to be bothered with doing a lot of layer 3, because any, as you know, route lookup is a very costly operation. Then another reason why you want to go with BGP is that it can carry any information attached to a route as an optional BGP attribute. You can define additional attributes that will be transparently forwarded by any BGP router that does not understand them. Basically, this means that BGP allows you to associate some characteristics or some colors to different routes that it carries. It's not just the routes, it is routes with some characteristics. And this can be very useful in coming up with different kinds of routing policies while distributing the routes amongst its peers. And one of the other